What's going on, guys? Christian here for Innovative IDM, and today we're going to be setting up a Yaskawa GA800 for the very first time. Okay, so let's look at what we've actually got inside the demo case. We have our Yaskawa GA800 here, an Omron power supply providing 24 volts. We have a Wago network switch, our AC induction motor, an Omron NB HMI, as well as a variety of switches, dials, and LED indicators. So what is the GA800? The Yaskawa GA800 is their new general application VFD. It's the replacement for the A1000, and it's perfectly situated for all of your general applications. Your fans, pumps, extruders, conveyors, whatever it might be. If you're not needing super tight positional feedback, the GA800 is going to be perfect for you. It comes in fractional horsepower sizes all the way up to 600 horse, and it can turn standard induction motors, permanent magnet motors, and synchronous reluctance motors. So we have a Wago network switch in here right now, and you might be wondering what kind of network does the Yaskawa GA800 work on? Well, pretty much any of them. It comes in Modbus RTU by default, but we can get additional network cards for Ethernet IP, EtherCAT, Mechatrolink, Profinet, Profibus. We're actually using the network switch to communicate with the HMI right now. Okay, so now I've got the keypad popped out of the chassis with an RJ45 cable. This could be handy for you if it's just easier to program for you, maybe just like as a handheld, or if you actually want to panel mount it this way so you don't have to open up your control cabinet to go mess with your drives or anything like that. You can certainly use it in this kind of setup. So this is the initial setup screen. We've got language selection. We can set a date and time here. Setup wizard is where we want to go. Go ahead and select that. Setup wizard will reset all parameters to factory defaults. Okay, that's fine. So first thing we're going to want to know is where's our speed reference coming from. So here we're actually using our speed pots on the demo case to adjust the speed. So I'm going to select analog input, but you can see here we can have it coming from a Modbus communications, another different type of network communications like an Ethernet, that would be our option PCB, or from the keypad itself. So we'll stick with analog. And we are actually doing 0 to 10 volts on ours. Okay, so right here it's telling us actually some setup tips here on the board of the drive. So if we pop this open, we would find that terminal that it's asking us to look for. We would use that AC common, and it's telling us where to set the dip switch so that we can use voltage instead of current signal. So that's cool. Select the run command source. So obviously we need to have a way to tell it when to go. Again, we've got all the same options here, but we're going to select digital input because we're using our switch. And then start-stop wiring configuration. If you don't know the difference between 2-wire and 3-wire control, that's fine. Just know for here we're doing 2-wire control, and it's telling us here by default where we need to land these wires from our switches. This is all default stuff. We can go in and change this at any time. Will an external fault contact be wired to the drive? In this case, yes. And it's going to tell us again where, if that's going to be normally open or normally closed, or is normally open. And it's going to tell us where to land that. So it's super helpful for drive setup. Select the load type, normal, heavy duty. Well, let's say ours is a fan or a pump. That's going to be normal. Anything else like a conveyor or an extruder or something like that, that's definitely going to be a heavy duty application. But we're going to say it's just a normal duty. And do we have a braking option connected to this drive? No, we'll say none. And then we've got motor type here as well. We've just got a standard induction motor, so we'll keep it there. Control method, we could do a whole different video on this. For now, let's just keep it on VF control. And select the motor speed control range. Again, variable torque, we're in a fan or pump application, so we'll keep it there. We've got a couple different options for stopping methods, so just think what makes sense for your application. Do you need to coast to stop? Do you need to ramp it to stop quickly? Are you considering DC injection braking or coast to stop with a timer? Let's keep it simple. We'll just do a coast to stop. It gives us some options here for acceleration time. I don't know, let's make it fast. Let's just do 1 second. Same thing for decel. And we can always adjust this, and this is particular to your application, of course. Should reverse operation be disabled? So this would be important if you're in a pump application or maybe a conveyor application or fan application as well, where you definitely don't want this thing running backwards. For ours, yeah, sure, let's say we should disable that. Okay, so now we get another chance before we input all these parameters into the drive. It's going to tell us, hey, this is all the stuff you changed. So we have a chance to look over all that stuff and change anything if we want. We did a good job, so we're going to apply those settings. Yes. Okay, so now we're going to continue. Test motor rotation and encoder feedback. Okay, so it's going to give us a chance to spin the motor at low speeds and make sure that what we think is forward is actually forward. So we'll hit continue, and we're going to press the jog key. And yep, our motor spins the correct way for our application. So we can say yes. If we say no, it's going to change a parameter for us to flip that. Obviously, you can always flip it with wiring, but you can also flip it within the drive parameters too if you'd like. Okay, so now we're setting the settings for the motor itself. It's going to ask us for input rating voltage, so we've actually only got 120 on here. Enter motor rated current, and all this stuff you can get from the motor nameplate itself. And right there, our setup wizard is complete. So you just set up a drive for the first time using the setup wizard, walked you through all of the stages and everything that you need to do, and you should be ready to make that motor spin. So we looked at a lot of stuff. Under the hood, right, you've got multifunction digital inputs, digital outputs, and you might be wondering, what else can I do with that? Well, if it's a super simple application, the Yaskawa GA800 actually has something called DriveWorks EZ, which you can use as basically a mini PLC just within the drive. So you can save a couple grand on the PLC and the IO cards and the software. If your application is simple enough, you can handle it all within the drive itself. And that's a free software that comes from Yaskawa. You can download it right now and try it out, and you can run simple logic and code in there, and you might be able to save yourself a couple grand. So that's pretty much it. That's all I've got to say about the GA800. Hope you guys thought this was interesting and cool. Hopefully you have some confidence to do this yourself. And if you don't, that's okay, because we are authorized service providers for the Yaskawa drives. And if you have us come and set them up ourselves, you get an additional year on your warranty. So something to keep in mind. I'm Christian for Innovative IDM. Thanks for watching.